Good morning students. In the previous video session you have gone through the work energy theorem, also the relation between the linear momentum and kinetic energy. Let's just discuss about this potential energy. We all know that the definition for the potential energy, and we know that what are the object which is in its position, it possesses potential energy, and we know that the rubber band possesses potential energy, and in front of us many object which is in its position. We can tell that that all possess potential energy. If we are saying about the example, now you can see the book in front of you is in a position, so that we can tell that it possesses potential energy. The fan in your house which is hanging on your ceiling, it possesses potential energy, but it lifted upside, so that we can tell that it possesses another type of potential energy which is called gravitational potential energy. So depending upon the situation, depending upon the configuration, we can tell that this potential energy we can classify it into different types. So potential energy means what? Potential energy means energy which is associated in a body with its position and the configuration with respect to its surroundings. We know that many objects in front of us which is staying at rest, which is hanging upside, which is moving, what we can tell means which is stretchable things are there. So all these possess potential energy, and we will see what are the types of potential energy we have. Before that, we have a small question here. Define potential energy and write an expression on it. It is a very important 3-mark question. Define potential energy and write an expression on it. So assume that here one object is there. One object is at the position P. Sorry, this is a point P, and assume that there is an object at the position O. Now the potential energy at this point P we are finding. So the potential energy at this point P, when we are finding the potential energy at the point P, so how we are finding means, how we can define means, the potential energy at this point can be defined. How you can define? How much work you have used to move this object from the position O to P. Assume that one object is here, and to move this object from this initial position to this final position, how much work is done? So how much work is done to move this object from the initial position O to the final position P with a constant velocity? That is what we can tell that potential energy. And if we are calculating the potential energy, we can tell that the potential energy at this point P will be 0. So we can write the derivation U is equal to integral of Fa dot dr. And what is this Fa? What is this dr? So this Fa means it is an external force which is used to move this object from the point initial position O to the final position P. And what is this dr? It is a displacement. You can see that it is displaced from this position to this position. So the potential energy of an object at this point P we can define as the amount of work done by an external force in moving the object at constant velocity from the point O to this final point P. So we can tell that at this initial position the potential energy is 0. So mathematically we can write the potential energy derivation or the expression U is equal to integral Fa dot dr. This is what a definition for potential energy. So again I am saying, so assume that one object is here at the point O, and in this point the potential energy of this object is 0. Now we are applying some external force on this point to move this object from this point to the final point P. So that that amount of work done by an external force. So when we are applying this external force, some work is done. That work done only that work done is the reason why the object moving from this point to this point with a constant velocity. And this is what we can tell potential energy. There is a definition which is given in the textbook also. You can see page number 176. So potential energy of an object at a point P is defined as the amount of work done by an external force in moving the object at constant velocity from the point O to the point P. At initial position the potential energy is taken as 0, so that you can write mathematically U is equal to Fa dot dr. So potential energy U is equal to Fa dot dr, and we have to integrate this equation with the limit to find out the potential energy from this point O to from this point P. This is a point which is called initial position, and this is a final position. So depending upon, we know that depending upon the configuration of our surroundings, this potential energy we can classify into different types. In that, the first one is, we can tell that the gravitational potential energy, and we know that from our childhood we are studying that the gravitational potential energy means. So gravitational potential energy means what we can tell. Suppose assume that one object is here. Now this object is we are rising against this gravitational force. We know that the gravitational force means which is always acting downward direction. But here the pen cap is there. Now I am lifting this upward. Now we can tell that this pen cap possesses gravitational potential energy. And you can tell the best example from our nature. We know that dams are built. Dams are built in a high position, so that we can tell that the water stored in the dams it possesses gravitational potential energy. And you can see that in your classroom the blackboard is lifted upward so that you can able to see the writings on the board clearly. So we can tell that the board possesses gravitational potential energy, because it is what we can tell means the energy possessed by the body due to gravitational force give rise to gravitational potential energy. So against this gravitational force, we are lifting some object upward and placing it that place, means we can tell that it possesses gravitational potential energy, and the equation we are using is U is equal to mgh. And the second type of energy is, we can tell that elastic potential energy. Elastic potential energy. And we know that what is this elastic potential energy means. So if you are taking a spring, so if you are stretching the spring or compressing that spring, we can tell that it possesses elastic potential energy. So the energy due to spring force and another similar force give rise to elastic potential energy, and we are using the equation U is equal to half kx square. So for example, if you are saying that if you have a rubber band, you can take and stretch it. When we are stretching the rubber band and when we are leaving the stretched force on that rubber band, we can tell that that rubber band possesses elastic potential energy. And the last one more type of energy given in for you is the electrostatic potential energy. So what is this electrostatic potential energy? So the energy due to the electrostatic force on the charges give rise to electrostatic potential energy, and you can write the U is equal to minus E dot of dr. So if you are seeing that we know that there will be assumed that here two charges are kept at these 2 points. So that you can tell that between these two charges it possesses electrostatic potential energy, and the equation we are using is U is equal to minus E dot dr, and we will study more about this electrostatic potential energy in your 12th grade. In 12th grade first unit we will study about all these things. So these are the types of potential energy given for us: gravitational potential energy, elastic potential energy, electrostatic potential energy. So gravitational potential energy, first thing you can define the potential energy. So what is potential energy? It is defined as the amount of work done by an external force in moving the object at constant velocity from this point O to the point P. So the expression is U is equal to Fa dot dr. And there are some types of potential energy. Gravitational potential energy. Gravitational potential energy means what? The energy possessed by the body due to gravitational force give rise to gravitational potential energy. And elastic potential energy means the energy due to spring force and the other similar force give rise to elastic potential energy. And this electrostatic potential energy means the energy due to electrostatic force on the charges give rise to electrostatic potential energy. And this is a 3-mark question. Types of potential energy. This is a 3-mark question and it is a book back question. Short answer question number 2. Short answer question number 2. The types of potential energy. You have to write the definition for gravitational potential and energy, and you can write this derivation expression U is equal to mgh, and you can write about the elastic potential energy. You can write the expression U is equal to kx square, half kx square. Then the last one is you can write about the electrostatic potential energy, and you can write this expression U is equal to minus E dr. Now you see, assume that we can find the expression for this. I said that we are moving here. You can see that this is the initial point O, this is a final point P, and against this gravitational force, we know that the gravitational force is acting this direction Fg, but I am against this gravitational force. I am applying some external force to move this object from this initial position O to final position P. So that the gravitational force is acting this direction and the external force which is applied is this direction Fa. So that we can write the gravitational force is Fg is equal to minus mg and j unit vector, because we know that this is a direction. So this is x-axis, this is y-axis. In x-axis we know that I unit vector, in y-axis we know that j unit vector, and this is in the minus j direction, so we are using minus mg. Now we know that you see, when I am applying some external force against this gravitational force, this external force is equal to the gravitational force, but what I am doing means I am applying the force which is in the opposite direction of this gravitational force, so that I can write the equation Fa is equal to minus Fg. So what is the meaning of this? So the force which is applied, Fa means the applied force. The applied force is opposite, but it is equal to what? Fg. So that is what this meaning. So let us find out the expression for this potential energy. We know the equation 1, U is equal to integral Fa dot dr, and we are lifting the object from this position, this initial point O to the final point P, and here some height from 0 to some height h I am lifting the object. From 0, this is the initial position, so we can tell that the initial position is 0. So from 0 to some height h I am lifting the position, so that you can put the limit 0 to h, then you can integrate this. So while integrating, we know that Fa means what? Minus Fg. So Fa is equal to minus Fg, and this you can keep 2, this you can keep 3, so that you can substitute 2 in 3. Substitute equation 2 in 3, so that we will get Fa is equal to minus of minus mg. So that Fa is equal to mg we will get. Now this is what you can keep equation 4. This you can keep equation 5. Now you can substitute equation 5 in equation 4. So that we will get U is equal to 0 to h Fa dot dr. So U is equal to 0 to h, Fa means mg, this mg dot dr, and U is equal to, take mg outside and integrate only dr, so 0 to h. The next step, U is equal to mg, and dr integration is r, so you can put the limit 0 to h. Now U is equal to mg, apply upper limit h minus 0, upper limit minus lower limit, so U is equal to mg h. So we got the expression. So this is what the potential energy, about the gravitational potential energy derivation, and it is one of the very important question, important 5-mark question. So first you have to write the definition. What definition you will write? Potential energy means what? Potential energy of an object at a point P is defined as the amount of work done by an external force in moving the object from this position point O to point P. From this initial position to final point I am moving some object, so that the expression U is equal to Fa dot dr. Now we know that when we are lifting this object from the point O to P, we are moving this object against the gravitational force. Gravitational force is acting downward, and the external force which is applied is upward direction. So that we can write the gravitational force Fg is equal to minus mg. We know that because it is acting downward direction, so it is in the minus j direction. So applied force is opposite direction to the gravitational force. So Fa is equal to minus Fg. Now next step, U is equal to, we can integrate the equation 1. So here you can write integrate equation 1. So U is equal to Fa dot dr 0 to h. We know that we are lifting the object moving the object from the position O to some height h. So we are giving the limit 0 to h. Now we can substitute this Fa value. Fa value is minus Fg. Minus Fg means what will come? So here finding, you see. So mg will get. Now put this mg here. Then integrate dr. Integration of dr is r. So we are giving the limit 0 to h. So while applying the limit, we will get mgh. And this is what you can see in the page number 176. So first you can write this definition, then this expression, then this paragraph. After that you can write this part and this paragraph you can continue, then the derivation up to 4.9. Then last you can write the same definition. Potential energy stored in the object is defined through the work done by an external force which is positive. So this is what you can write down. So my dear students, all of you go through this video and learn about this potential energy. And next part is elastic potential energy. This is your deleted portion. And 4.2.7 conservative non-conservative force, that is also deleted part of. And 4.2.8 is law of conservation of energy, that is also a deleted portion. And next topic we are going to study is 4.3, that is about power. So my dear students, all of you study this and revise this. Thank you all. Bye bye.